have to hit that song like when I was semi-pro every time, every game.
Well, I will tell you that to do this kind of work, everybody that's done this kind of work very much knows you got to be a little tougher and a little smarter than everybody else. You know, and there's some people that can try it, but they'll never make it. You don't want to be one of those people that tries it but never makes it. You know what I mean? No half-hearted people, you know, that wants to be somewhere else and all that. You know people doing work like that, do you?
Not at all.
All right, who's ever come out and found a battery dead on your car in the morning?
Yeah.
You ever did that? What was the reason for it? Did you find a reason for it?
The headlights on.
Left the headlights on? Now, why did you leave the headlights on?
You got one person sometimes.
It was foggy maybe, and then the fog burned off while you were driving, and then you parked the car. What was yours? What about yours?
The lights on inside.
Left the lights on inside the car. I left the glove box open on a car I had one time, killed the dadgum battery. You know, duh. You know, what about you?
I guess it was the light on it. It was just dead.
Yeah, just dead. Never did go dead anymore. What about you?
Yeah, I'm talking about dad.
My grandmother left the inside lights on.
The inside light on. What about you? You had yours happen?
Dirty times.
Okay. All right. All right. The battery is sort of like a reservoir. The electrons want to be on one side of the plate and submerge in the electrolyte. When they get to decide where they want to be, the battery's dead. So when all the electrons finally make the pathway over to the other side of the thing, you got a dead battery. Now we're going to say they want to go to the negative side. Who cares which you switch? It doesn't matter. You can't see electrons anyway. Now electrons, those one guy, these two guys both won Nobel Prizes 30 years apart, and they were father and son. And one of them showed that electrons behaved as waves, and the other one showed they behaved as particles. And the one, his son figured out they only behave as particles when they're being observed. If that doesn't bother you, you won't listen to what I just said, okay? Well, they kind of know what each electron knows what every other electron's doing, right? So they're all wanting to go to the other side. So let's turn the battery so the ground's at the bottom. So let's say each chamber is perfectly sealed so no power can move unless there's a connection between the plus and minus side. Now occasionally, you'll have a short circuit that will happen inside the battery. I haven't seen a battery where you pull up there, everything's just fine. You go to start it up, you know, 15 minutes later, it won't start. And if you happen to pop the covers off, better be wearing your safety glasses, one cell will just be boiling to beat the band because it's got an internal short. The battery in my Explorer, about, I don't know, a couple of months ago, I drove over to Geneva, parked the vehicle, had no problem with it, sent a student out there to get it over there, and whenever he went to get in it, it turned, and when it started, he goes, what's the trick to starting your vehicle? I said, what are you talking about? He goes, I can't get it to do anything. I said, oh, come on. It wouldn't even burn a light on the dash. The battery had just gone totally south. It was under warranty, you know, I got to know. All right, so the electrons desperately want to go where they would rather be, the other side of the plate. So when we charge a battery, we're forcing them to go back up here, because, you know, like filling this up. So it's kind of like a windmill pumping water uphill into a big tank. It wants to go back to where it came from, but it can't unless a path is provided and something pushing it. So the battery charger is like a pump that's pumping the electrons from the hot side of the battery. This right here is like your windmill. See that? So your battery will be the storage tank, and it's getting it from there. This all wants to go back down there. See? Now, every electrical load on the vehicle uses some electron flow to work. Magnetism will produce these. You're providing a path for that to flow, and it's also doing work on the way, right? And some electronic components have got capacitors, little reservoirs that store electrons for later release. And when the path is provided through the load, you're actually able to do some work. Batteries that are totally dead can actually be charged up backwards. When I worked at that gas station back in the mid-70s, some of these Farmer Brown, just about everybody had a battery charger, right? And they killed the battery, left the lights on, whatever, and they would take their battery out of the vehicle and they'd set it on their floor of their barn, and then they wouldn't be able to see good, and they hooked the battery charger up backwards to the battery and turned it on all night. The next thing you know, the battery's got a backwards charge on it. Totally reverse charge. Now nowadays that would be a disaster with a capital D. But what they do is they go to put it back in there, when they put the battery cable back on, it spark real big, and they say, oh, and they realize what they've done. They bring it over here. We would put a light bulb on it and leave the light bulb on it until it ran it completely down, then we would charge it back up the other way. You know, a lot of people don't even remember those days, but anyway. So when is the battery dead? According to GM, using up about 40% of the Available amp hours will usually take a fully charged battery to a no-start condition at moderate temperatures of 25 degrees Celsius, which is 77 Fahrenheit. Put another way, for a typical battery in a storage situation, depleting the available amp hours by 20 to 30 amp hours will result in low start condition. That's amp hours. Most folks like to refer to cold cranking amps. A good tester can tell you how many cold cranking amps a battery has left in it. That's what we got in this little out here. Batteries tend to lose their ability to store power over time. A battery's like a sort of a gas tank, so to speak. So every year it's going to get a little bit less likely to hold its charge. You know, it's going to lose some cranking amps until it gets down. And you may, the rule of thumb for the people that sell used batteries is 1 cold cranking amp per cubic inch. Used to be, you know what I'm saying? Like if it was a 350 engine, if you had 350 cold cranking amps, it usually started. Now most of them got. And Ford there for a while, back in the late 70s, were putting some of the tiniest little batteries in their cars that you've ever seen. They had little bitty batteries in there. It's the biggest joke. Everybody wanted to put a great big fine battery in there when those sound like crap down, they always did. Now, about them there amp hours, 2 different measurements. 120 amp hour battery can deliver 1 amp for 120 hours. You got that? Memorize this and go ahead and pop test on it. Wake up. All right, 2 amps for 60 hours, 3 amps for 40 hours, or 4 amps for 30 hours. Get it? Are you getting the math here? You got it? You can do that. Cranking amps is the number of amps a lead acid battery at 32 degrees Fahrenheit can deliver for 30 seconds and maintain at least 1.2 volts per cell. You getting where we're going with that, right? Reserve capacity is the number of minutes a fully charged battery at 80 degrees Fahrenheit will discharge 25 amps until the battery drops below 10.5. This will be on your final. Remember this, okay? Do not forget this. Take notes, burn it in, put it in your hard drive, do whatever you have to do. So if losing 40% of the amp hours would drag this battery below the point it would start the car, you can see how parasitic drain, even a small one, might be an issue. Okay? All right. Now, some electronic modules on newer vehicles, late and 2 model, have capacitors that need to charge up when the battery is first connected. Now, it's like a little battery that stores the charge, but only for a few seconds. And it takes a little while for all the capacitors to charge. So keep that in mind before you start pulling fuses. All right. So be like your modules that have got little teeny tiny batteries in them. But a capacitor. This is a capacitor, and some of them also look like that. They come in various different sizes, and they're measured in farads, microfarads, and all that. And it's got a negative side and a positive side. Now you can take this right here and charge it up with 12 volts, and hook your meter up, and you can measure 12 volts coming out of that little capacitor. You got that? The condenser in an old distributor is a really powerful capacitor, and you can let the spark jump to the wire on the end of that thing, and whenever it stores at 30 or 40,000 volts, if somebody comes and grabs that can and touches into that wire, it'll knock the tar out of them. You know, these big capacitors, like in the air conditioner, you can charge one of those things up with 220 volts, and when you short it with a insulated screwdriver across there, it sounds like a shotgun going off. Boom! The big lightning bolt. Anyway, so generic layout. The battery typically feeds an underhood junction box with large fuses, small fuses, and some relay. Each large fuse may feed several smaller fuses in the interior box. Some of you guys are already reading my mail. You know where you've been. Dakota's thinking about the times he's had to do this right there, right, Dakota? All right, so you've been there. All right, so finding the drain means you got to eliminate the the circuits that aren't drawing the current. So you got to find out what it's not. So when you have the battery disconnected and you insert your meter, you got to allow the capacitors in the modules time to charge up. This can take an hour sometimes. We had a Mustang this lady brought up here. It was like a 2010 model, and there's various different ways you can do this. We talked about doing it with, you know, forward-looking infrared camera and all this. But anyway, on this particular one, since we had some time, we set our meter on amps, move the leads where we made the meter a jumper wire, right? Know how to do that, right? And you hook it up between the battery terminal and the wire you took off the battery terminal. And so anything that's going through that meter is going to be red on this little screen. Okay, it's not supposed to have more than 50 milliamps. This one here was showing a pretty good bit. So I said, let's walk away. Just leave it there, walk away. So a little bit later, 45 minutes, an hour later, we came back and all of that had gone away. So what that means is it had charged up all of its capacitors, everything was good. So we went ahead and did a double check on her battery, because you know usually it was starting, but it seemed like it was dying overnight. She had a bad battery. Her battery's killing itself. What it amounted to. And sometimes it'll happen. If you pull the battery cable off and leave it set overnight, and then you put it back on, the battery's dead, in spite of the fact it was disconnected, that's a bad battery. The battery can kill itself, right? All right. Amps measured here. See, we're measuring amps right there, going through the fuse box. That's what we're basically measuring. There's what our amps is. When you've had a battery disconnected. All right. Now, we actually have pulled all the other fuses, and we found out that that one right there, see, you might remember this right here was feeding a whole bunch of fuses here, but as we pulled all of those, this stayed the same, but when we pulled that one, the draw went away. You got it? All right. Yeah, this is a fairly common procedure. I think that may be a, is that a video? I don't think it is. That may not play. It's trying to play. 35 seconds. Yeah. Okay, this one here has a draw. We got that computer set up to read how many amps is going out of the battery. She's got a problem. Well, after we pulled all the fuses, what we found out was when we pull the stop lamp fuse, the draw goes away. And when we put it back, the draw comes back. So now what we got to do is find out what it is that the stop lamp switch or stop lamp fuse feeds besides the stop lamp, because they're not on. All right. Now then, moving along. That's the Mustang I was talking about. That one there. Now, I just mentioned that a minute ago. We don't need to keep going. But you can see how we got it wired up. Battery terminal, the battery cable hooked up to these two. I don't have that little thing in a place, but you're going to have it on that setting right there. Okay. Now I need to do this. Drive it and operate all the options during the test drive. Then turn the key off, wait for all the modules to go to sleep. They take a while. Alright, so you can also measure voltage drop across each one of the fuses. There's been a lot of stuff in Motor Age about this lately. A lot of people have been doing it for a long time. I don't know who came up with the idea, but it's a good one. The fuse has current flow will have measurable voltage drop. You don't put your meter on the really low reading so it'll read just the tiniest little whisper of voltage. If there's any current flowing, if you've got a connection, it don't matter if it's a solder connection or if it's a fuse connection or whatever, there's going to be a little bit of drop there. As a matter of fact, a wire 60 feet long has got some drop. It's got like an old one. All right, so simply set your to the lowest millivolt scale and place the leads across the fuse. Now they're showing them, they pop the covers off of these fuses right here so they can get to those. That's something you can do, but it takes a little time and effort and energy to do it. An inductive meter around the negative cable can read current draw without disconnecting anything, but you'll still have to isolate which circuit's guilty with. Positive cable may be tough to probe that way, too many branches. I like to take the oscilloscope with my little inductive lead and put on there. We've done that before, and you can see on the oscilloscope it'll show amps. And then you can keep fooling with stuff until it drops out. That way you haven't disconnected anything, you're just going inductively around the wire, right? And that works pretty good. Or you can use one of these meters right here. Maybe one of these gates like this. You can buy those. If you have to keep the door open to gain access to an interior fuse panel, that may keep interior circuits live and drawing current. I was doing this really early in my career, and I was fighting and finally found out, oh, look, it's coming through the courtesy lamp. Oh, man, I got the door open. No wonder, duh. You know what I mean? It's just an easy mistake to make if you're not careful. Now, what you got to do in order to trick the door switches, some are built in the door latch. So you got to actually take that out first and see if you're, you know, of course, if that happens to be the one that's feeding your current draw, you're going to have some issues with that, right? Thermal imaging works pretty good. The vehicle has been sitting for a while, like several hours. There shouldn't be any warm fuses or relays. You can use that in conjunction with an inductive meter to track parasitic draw. You shoot that thing with that FLIR kit range, you're going to wind up with that. And I got one that plugs into my phone, you know, that you're going to do it really quick. All right, you're going to see me go through this issue. You're going to get used to it. You need to get good at it. Parasitic drains are often the radio, but they can be just about any module in today's network-intensive vehicle. We worked on one when Zach was here. I may have mentioned that the other day. It was a Buick that we worked on that was killing the battery. Was that your mama? Didn't your mama have a big Buick that was killing the battery? That was her car, wasn't it? And so what we did was we hooked up to it, and it had a fuse panel under the seat and all this other, and we had the door, you know, we killed the interior lights and got under the seat, and I was reading the amps, and Zach was back there pulling fuses. When he pulled the fuse, it fed the radio, and it was under the back seat. The radio turned out to be what the problem was. And so what we did is we went and disconnected the radio. You know, or just left that fuse out, I can't remember. If the radio is fed by that fuse and there's nothing else fed by that fuse, you can just leave the fuse out. You know, if the customer doesn't turn on the radio and all that. Find all the fuse panels, every one of them. All right, so do you know something now that you didn't know before?
Yes.
All right, have you done parasitic drain stuff? And you got to remember when you're doing something, and this is something you need to think about, don't neglect to check the dark side. You don't know the power of the dark side, right? The dark side is the ground side, right? The ground side is the dark side. A lot of times people will miss the ground side when they're checking a circuit because they're thinking power, 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 power. But you can have a ground issue. Like one time, I always got so tickled thinking about this Mustang that came in there that we just turned the key, wouldn't do nothing, and he got a test light and he hooked it up to the terminal that goes and tells the starter to spin, and he had light there. Must be something wrong with the starter as far as he went. So he busted his rear end and changed the starter on that thing, and then whenever he put it back in, it did like it would, nothing changed. Well, you could take the test light and hook it to the ground side of the battery, right? And you could touch the engine block and turn on the key and the test light would light up. So you're going from ground to ground and it lights up the test light? Is that supposed to make sense? The only way that ground was able to get through there was through the test light, because the ground going up under there on the side of the engine block. We looked at it and it looked clean, it looked tight, it was nearly a new car, but they had anodized that bolt with something that wasn't conductive, and we took the bolt out. Real aggravating to get to. We took it out and we brushed the bolt on the wire wheel, and then we used this sandpaper and wire brush to brush the terminal in the block and get the paint off the block and all that kind of stuff and clean it all up. Put it back up in there with a star washer and tightened it up real tight, and we had main engine burn. But see, missing the voltage drop test to start with is what cost him all that extra work. Now, raise your hand if you like a bunch of extra work. I don't see any takers. All right, then. Okay, so that's the point. I mean, like I say, you gotta be able to, if you understand this stuff, and I'll tell you what happens when you go to, Lee is over there, you know, working at Lincoln, right? He's over working at Lincoln, and whenever they decided we're going to send him to manufacturer school, and so one of the very first schools they sent him to after he was through with all his computer work, because they got something like electude in these schools. I mean, in the dealership, you've got to go through that stuff before they can even send you to school, right? And so, and I actually had one student that got let go because he wouldn't do it. He felt like I wasn't worth his time, and so he lost his job. So they don't go that route, you know. Anyway, he went through they go through all the training modules on the computer, sent him to school, and he told me, he says, the first school he sent him to was electrical school. Got it? And he says, but you know what? He says, this electrical school is really, really easy because of the way you taught electrical when I was with you. And some of these other guys are terrified, scared to death, because they hadn't been taught. And the thing about it is, a lot of the procedures I use, I learned from Ford when I was at Ford school. I built my trainers a very similar way, you know. So today, what you guys are going to do is I'm going to have y'all to wire up the fan board. Okay, the fan board is good. It is our friend. Okay, okay. So what we're going to do here, we're going to zoom in a little bit on the fan board, and you can see that we've got 3 relays and 2 switches. We've got battery power here. And so what would you do if you were going to make these fan motors run at half speed? If you were going to have 6 volts, you got 12 volt battery back here, if you're going to have 6 volts going to each fan motor, what's going to happen? Sir? Well, yeah, but I mean, how would you get, if you were just going to wire it up so that these fan motors were going to run half speed, how would you do it? In other words, you got 12 volts, got a good strong 12 volts available here. If you're gonna wire it up, show me where would you put your power? If you put your power, let's just try this. Let's put the power here. And this is not how the board's got to be wired up, don't get me wrong. All right, and then we're going to go from here to here. Looks like I got a good power back there. And then we're going to go from here. Is it long enough? Not even long enough. I need two of them put together. I'm going to put that one right there. We got no power. Well, we got a bad jumper wire. We get a different wire. All right, somebody got me a test light? Give me a test light. Give me a test light. Oh. I need it. We got a good fuse here. Nothing wrong with our fuse. We had a test light. It was bad yesterday trying to work on that Ranger out there looking for something. And when we hooked our test light up to ground and we touched it to the hot side of the battery, it lit up. And then we touched it to what we were checking, it didn't light up. So we went looking for where the power was being lost. And then I touched it back to the battery and it didn't light up. And then when I wiggled the lead, it lit. It unlit. So it cost you extra trouble. You better double and triple check your test light. All right. First thing we're going to do when we're in any situation like this is check and see if we have power available there. It looks like we got an issue there. All right. Yep, we have good strong power there. Gotta make sure we got good strong power here. All right. There we go. There, now. We just have back connection behind the board. See it running at half speed? All right, now if I take my meter, hands are running at half speed. It's also, these wires on here are kind of weak. So we're going to take this right here, and we're going to measure the voltage. Hold that, Timothy, so the camera can see it, the people can see it. We're on voltage. And we got, only got 3 volts showing right there. Probably because we're dropping some voltage on one of these crappy jumper wires. Now what do we have right here? We got about 2.2. See, the quality of those jumper wires and how wore out they are, they all have ruined my jumper wires hard to put them up with. That's what you got to have there. What would I do if I wanted to speed these things up and make them run full speed? You got any idea? This is what I would do. I would go from here, and then we'll ground that one. See, that one's running a little faster than this. Then I'm going to provide a dedicated ground to that one right there. Now once again, these wires right here, I got to get some better wires before I wire up this board. We'll find you some good ones. See that? You basically, if you put a dedicated ground, and I didn't like the way that was running, because they were dropping voltage through some bad jumper wires. Here's the point. And you need to know the answer the next time I ask you. If you're going to wire them so that they run half speed, you got to wire them in series. That means power to here, this one to that one, and go from here to there. Right? Now, if you want them to run full speed, you got to have a dedicated ground for each motor. Now, the circuit I've got set up here is going to be set up so that when you turn this on, it'll be going through these relays so that the power is going through both motors before it finds ground. And then when you match that one, it energizes 2 relays, and it causes each motor to get its dedicated ground. You know what I'm saying? But that's the way cars, a lot of cars have got their fans wired up. And that's how you need to understand that so you know how to do it. That's why you need 3 relays and this. Now I've also noticed on my schematic right here, relay 2 on my schematic is upside down. Don't get confused by that. In other words, the common is down here and the normally open and normally closed are up here. So when you're looking at this schematic, make sure you catch that, okay? Really important. All right. Now, let's see if you got some better jumper wires and we're going to make this happen.